Hi everyone, we are from Zhongling High School. The science principle that we are going to share today is the Bernoulli's principle. We are going to begin with the overview of Bernoulli's principle, followed by the examples of experiments that we have done previously and a short conclusion of the Bernoulli's principle.
Now, I'm going to make some explanations about the Bernoulli's principle. So, what is Bernoulli's principle? According to our research in fluid dynamics, Bernoulli's principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or decrease in the fluid's potential energy. Do you still remember the Wright brothers? They also applied the Bernoulli's principle in the invention of aircraft. Their invention explains that an aircraft can reach lift because of the shape of its wings. I believe that this will be the most successful application of Bernoulli's principle. In today's topic, we'll basically focus on how both speed and pressure affect each other. Before that, you have to know that the inverse relationship between the speed and pressure at a point in a fluid is called as Bernoulli's principle. At points along a horizontal streamline, higher pressure regions have lower fluid speed and lower pressure regions have higher fluid speed.
Let us move on to the example. We have prepared 4 simple experiments that can be found in our daily lives. For the first experiment, I will use a single sheet of paper to explain the Bernoulli's principle. I will blow air above the paper and the paper will lift up. Now I will demonstrate it with a piece of paper. Why? Why will the paper lift up when I blow air above the paper but not under the paper? It is because of Bernoulli's principle.
What I'm showing right now is one of the experiments of Bernoulli's principle. What's the observation in this experiment? As you can see, what I've labeled, the water flows in a faster speed at part B compared to part A. So, what causes this to happen? According to the Bernoulli's principle, the higher the pressure, the lower the velocity. On the other hand, the lower the pressure, the higher the velocity. The decrease of area from part A to part B causes the change of pressure in water. Therefore, the velocity of water at part B is higher, which makes the water flow faster.
Here's another example of the Bernoulli's principle. When there's a strong wind, the roof of the house will be blown away. Here's a demonstration of it. Due to the high air velocity above the roof, it lowers the pressure. This causes the higher pressure inside the house to lift the roof upwards. As how we demonstrated just now, the strong wind above the roof causes the higher pressure inside the house to lift the roof upwards.
Ever wondered how birds can fly? Here's a chicken wing for example. How do birds gain altitude with the shape of their wings?
Let's take a close-up look at the chicken wing. The aerofoil is the cross-sectional shape of the wing. It can be viewed clearly since we cut the chicken wing in half. How do you think this shape can cause lift?
So how is the Bernoulli's principle involved in the wing shape? The air above the wing travels faster than the air below. So how do we justify this statement? Imagine if there were 2 men at point A and point B. Both of them want to meet up at the same time at point C. The man at point A has to travel at a faster distance because he has to cover a longer distance. Applying the same theory to air, the air on top of the wing has to travel faster. Therefore, it creates a low pressure region, and the air with higher pressure lifts the wing upwards.
As we look at the wing, the air travels at a higher speed in this direction, whereas it's slower on the other side. That enables the chicken wing to lift.
And that is how the Bernoulli's principle is applied in modern aircrafts and birds.
All in all, Bernoulli's principle explains that the smaller the area or the lower the pressure, the higher the velocity. That's all for our presentation today. Thank you and goodbye.